Hello everybody, getting ready to do lesson 7.3 part 4 classwork for pre-calculus math today. And today, 7.3 part 4, you have 1 point that goes in your notebook and 48 points in your classwork sheet today. 7.3 multivariable linear systems part 4. So this is your notebook entry here. The next example shows how to find a partial fraction decomposition for a rational function whose denominator has a repeated linear factor. So repeated linear factor, that's the key phrase there. So let's see what we got here. So for example 7, partial fraction decomposition, repeated linear factors. Write the partial fraction decomposition of this expression here, 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. The expression is proper because our degree appears less than our degree in our denominator. So factor the denominator. So we need to factor our denominator because the denominator factors as x cubed plus 2x squared plus x is the same thing as x times x squared plus 2x plus 1, and then this factors down to x times x plus 1 squared. You should include one partial fraction with a constant numerator for each power of x. So in x plus 1, and right, this becomes here we have a cubed here, so we have 3abc now. We have 3 constants, so we have to put in for each power of x in our denominator here, which is a cube. So now we have a, b, and c. We have a over x, which is here, then x plus 1, b and c over x plus 1. So this is our expression here that we can start with to decompose this denominator here. So once we have that laid down, multiply by the LCD, which is x times x plus 1 quantity squared. And it leads to the basic equation of this. So we have 5x squared plus 20x plus 6 equals a times x plus 1 squared plus bx times x plus 1 plus cx. This is our basic equation here. Now, when we expand this out, we get this big, long, gnarly thing here. When we expand this here, 5x squared plus 20x plus 6 will be expanded out to this expression here. And when we do that, after we do our expansion there of it, we have our polynomial form now of it. So we have a plus b x squared plus 2a plus b plus c x plus a. And then when we plug in now, equating coefficients of like terms on opposite sides of the equation. So now we have this situation here. 5x squared will become a plus b x squared. And then 20x will be 2a plus b plus c. And then our constant here will be a. So here's our setup here to move over into our next manifestation of our decomposition here. Produces the following system of linear equations. So now we have a plus b equals 5, 2a plus b plus c equals 20, and then a will equal 6. So now we have our 3 equations from that decomposition. Substituting 6 for a, and equation 1 yields what? So we have 6 plus b equals 5, b equals -1. Now, we can substitute that in. We can back substitute that in. Substituting 6 for a and -1 for b in equation 2 yields what? So 2 times 6 plus -1 plus c equals 20. C will equal 9. So now the partial decomposition is this expression here becomes 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. Check this result by combining the 3 partial fractions on the right side. So when you combine these things of the equation, or this is much easier here, by using a graphing calculator. So this on your graphing calculator should show the same graph as this over here. Okay, so let's go into our guided practice here. On these exercises 65 here, write the partial fraction decomposition for the rational expression. Here's our rational expression. Check your result algebraically by combining fractions, and check your result graphically by using a graphing calculator to graph the rational expression and the partial fractions in the same viewing window. So our first step here of doing that, this becomes, we're going to go a over x, and then b over x squared, and then c over x plus 1. When they've already got this factored down for us here. We have an x squared there, and then that will be our b over that x squared. And then when we do that, when a polynomial form of that expression becomes this, ax times x plus 1 plus b times x plus 1 plus cx squared. And then when we combine like terms here, when we do our multiplying through, we have a plus c times x squared plus a plus b x plus b is what we come up with from that. And now when we substitute values in, we have a plus c equals 4 for this situation. The a plus b will equal 2 for that situation. A plus b will equal 2. And then b will equal -1, which is here, -1. So we have 4, 2, and -1 in our numerator. And that's what our a, b, and c's are amounting to. And then when we further that out, b here equals -1. And then a will equal -3. Or no, a will equal 3. And c will equal 1. So a will equal 3, 3 plus 1 will equal 4, and then c will equal 1. A plus b, c, yeah. And then now we end up with this final manifestation here of our decomposition of the rational expression. It'll be 3 over x plus -1 over x squared plus 1 over x plus 1. Okay, example 8, vertical motion. The height at time t of an object that is moving in a vertical line with constant acceleration. Here's a diagram here of this problem. A is given by the positive equation s equals 1/2 at squared plus v naught t plus s naught. The height s is measured in feet, so our s here is measured in feet. This is our s here. S is measured in feet. The acceleration a is measured in feet per second. Measure a is feet per second squared, and t is measured in seconds. V naught is the initial velocity in feet per second at t is equals 0. So here's t equals 0 here. And S naught is the initial feet, so S naught would be here as well. This is our S, and then this is our T equals 0 here. Find the values of A, V naught, and S naught. So we need to find our values here of V naught and S naught here. Find the values of A. We need to find the values of A there as well. So how do we do that? S equals 52 at t equals 1. We know that's t equals 1, s equals 52 up here. And then s equals 52 at t equals 2. Back in over here, this is our kind of like our maxes up here. But again, when at t equals 2, s equals 52 again. And then when s equals 20, t equals 3 down here. So at s equals 20 at t equals 3. You can obtain 3 linear equations in A, V naught, and S naught as follows. So let's see how we can interpret this result here by using 3 linear equations, or basically a system here of 3 linear equations to express this motion here. Okay, so our next step in solving this problem here is let's get a array here of problems to put up here when t equals 1, and then here is our function here based off of that. When t equals 1, when we multiply through by 2, we get this expression over here, a plus 2v naught plus 2s naught equals 104. And then our next linear equation, when t equals 2, again, when we multiply through here, when t equals 2, this equals 52. And then this time here, this cancels out here. 2 times 1 is 2. And then this stays the same here for 52. So it's 2a plus 2v naught plus s naught equals 52. And then when t equals 3, we have 3 1/2 here, or rather we have 3 squared, and then we multiply through by 2 again here, and we get 9, and then this becomes 40 out here because you multiply through by 2 again to clear our fraction on that one. So solving the system yields a equals negative 32, v naught equals 48, and s naught equals 20. This solution results in a position equation of s equals negative 16t squared plus 48t plus 20 with this model here. Okay, let's try a problem like that now after we finish up here. It implies that the object was thrown upward at a velocity of 48 feet per second from a height of 20 feet. So from a height of 20 feet, our average velocity is 48 feet per second from a height of 20. So let's try one here. In these exercises, an object moving vertically is at the given heights at the specified times. Find a position equation, s equals 1/2 at squared plus v naught t plus s naught for the object. So at t equals 1 second, s will equal 128. At t equals 2 seconds, s will equal 80. And then at t equals 3, s will equal 0 feet. So with that in mind there, here is our original expression here. And then here are our ordered pair here for the position of the object. So 128 in this situation here, 128 will equal 1/2 a plus v naught plus s naught will equal a. See, 128 at a will equal a. We have to clear our fraction here, so a plus 2v naught plus 2s naught will equal 256. And then for 80 here, when s equals 80, t equals 2. So again here, 2a plus 2v naught plus s naught will equal 2a plus 2v naught plus s naught will equal 80 in that situation there. And then at 3 seconds, we will come up with a 0 here. That's what our conditions will produce here when t equals 3, s equals 0. So solving the system, a equals negative 32. When we solve the system, v naught equals 0 and s naught equals 144. Thus, s equals 1/2 of the negative 32 t squared plus 0t plus 144. And then this simplifies to negative 16 t squared plus 144 for find a position equation for these situations here, and then here it is here. Okay, so let's go on to our next example here. Data analysis, curve fitting. Find a quadratic equation y equals ax squared plus bx plus c, whose graph passes through the points negative 1, 3, 1, 1, and 2, 6. So because the graph of y equals ax squared plus bx plus c passes through the points negative 1, 3, 1, 1, and 2, 6, you can write the following. So when x equals negative 1, y equals 3, there's that point. And then here is our input here into our quadratic here. A equals negative 1 squared plus b times negative 1 plus c will equal 3. And then when x equals 1, y equals 1, That will be a times 1 squared plus b 1 plus c will equal 1. And then when t equals 2, y equals, or rather when x equals 2, y equals 6. So a times 2 squared plus b times 2 plus c will equal 6. So what do we do with that? Well, this produces the following system of linear equations. Here's our linear equations here from that set of conditions: a minus b plus c, a plus b plus c, and 4a plus 2b plus c equals 6. The solution of this system will be a equals 2, b equals -1, and c equals 0. So the equation of the parabola is y equals 2x squared minus x, and here is the graph of that solution. Okay, so going into our guided practice here, we need to find the equation of this parabola here that passes through these points here. So we need to find the equation of that graph that passes through the points here. To verify your result, use a graphing utility to plot the points and graph the parabola. So here are our points here. So our first step in that, we have 0, 0, so 4a plus 2b plus c, because here's our 4a here, 4, 0, plus 2b plus c will equal, c in this case will equal -4a minus 2b. And then for 2, -2, we have -2 will equal 4a plus 2b plus c will equal -1 equals 2a plus b. And then for 4, 0, you have 0 equals 16a, 16a plus 4b, and what we get from that is c will equal 0. 0 will equal 4a plus b. So that is our generation. From the data that we're given, we can derive these values here for our entries. So when we do that, here's 0, 0. There is 2, -2, and then here is 4, 0 there. There is our partial graph there of our parabola. So the answer would be a would equal 1/2, b would equal -2, and c will equal 0. The equation of the parabola would be y equals 1/2 x squared minus 2x, and then we have no c here. So here is our equation of the parabola that's represented by these points here, and then that would be your graph of the actual parabola. And that is 7.3 part 4 of your classwork for pre-calculus math. Here's my email if you need course materials, solution PowerPoints, classwork sheets, note-taking sheets, homework sheets. Thank you.